Hello, good day viewers. In this tutorial, we will be evaluating the cube root of 1. Remember, in the real world, the cube root of 1 is just equal to 1. But what about in the complex world? That's what we are going to be looking at in this tutorial. Okay, according to one of the laws of indices, cube root of anything is the same thing as that thing to the power of 1 divided by 3, right? And we can represent this using a complex number, because 1 is a complex number where the imaginary part is 0. So let z be equal to this 1, which is a complex number where the imaginary part is 0. So now let us write this complex number in a polar form. You know, in a polar form, z is equal to r multiplied by cosine of angle subtended by that complex number plus I sine of that same angle. So we're going to find the r and the angle. Okay, since we have only 1, the imaginary part is 0. On our cycle, this is the real axis, right? So it's just 1 unit to the right. So we have 1 unit here. And you can see the angle here is 0, right? 0 degree or 0 radian. If you make a complete cycle, you're going to obtain 2 pi. Another cycle, you have another 2 pi. Therefore, 0 radian is the same thing as 2 pi times k, where k is an integer. That is multiple of 2 pi is the same thing as 0 radian. Therefore, we can say that the angle subtended is either 0 radian or 0 degree, or even multiples of these 2 pi. And the distance, which is the modulus r, is 1 unit, right? The absolute value of 1 is 1. So we can write this complex number as z equal to r, which is 1, multiplied by cosine of 2 pi k plus I multiplied by sine of 2 pi k. But remember, we are looking for the cube root, which is to the power of 1 over 3, right? Therefore, our z to the power of 1 over 3 is the same thing as cosine of 2 pi k plus I sine of 2 pi k to the power of 1 over 3. And according to De Moivre's theorem, this power can multiply this argument. So let's do that. So this becomes the cosine of 2 pi k divided by 3 plus I sine of 2 pi k divided by 3. So once we simplify this, we are going to obtain the cube root of 1. Observe, this is a complete cycle partitioned into 3. You know, a complete cycle is 360 degrees. If you divide it by 3, you're going to obtain 120 degrees each, right? So let's demonstrate this on a cycle. So if we have a cycle like this, you know, this is our 2 pi, right? That is 360 degrees. If you partition this cycle into 3, you're going to obtain 120 degrees each, which is what? 2 pi divided by 3. So we have 120 degrees somewhere here. And if you add another 120 degrees, you're going to have a reflection of that one to the third quadrant. So you see we have another leg here, which is the origin. That is 0. So every terminal point here will be a solution. We have 1 here, we have 1 here, and we have the other one here. So now let us start with this terminal point by setting k equal to 0. So if k is equal to 0, we have the whole of this to be equal to 0. We have cosine 0 plus I sine 0, right? So our z to the power of 1 over 3, which is the same thing as cube root of 1, is equal to cosine of 0 plus I sine of 0. This is equal to cosine of 0 is 1 and sine of 0 is 0. So we have only 1. You see, cube root of 1 is equal to 1. So if you want to get to this point, you're going to set k to be equal to 1, right? So if k is equal to 1, we have our cube root of 1 equal to cosine of what? 2 pi divided by 3 plus I sine of 2 pi divided by 3. This is equal to cosine of 2 pi divided by 3 is negative 1 divided by 2 plus I sine of 2 pi divided by 3 is root 3 divided by 2. So here is another solution. And you know that whenever we have a complex solution, its conjugate will also be a solution. Therefore, the third one will be equal to negative 1 divided by 2 minus I root 3 divided by 2. This is just the conjugate of this one. They are conjugate of each other. But let us just find it on our cycle. If we set k to be equal to 2, we are going to reach onto this terminal point. By multiplying this by 2, we have 4 pi divided by 3, right? So let's see that. 1 over 3 will be equal to cosine of 4 pi divided by 3 plus I sine of 4 pi divided by 3. Cosine of 4 pi divided by 3 is equal to negative 1 divided by 2. And the sine of 4 pi divided by 3 is negative what? Root 3 divided by 2. So we have negative I root 3 divided by 2. Can you see they are exactly the conjugate of each other? And without even doing this terminal point is just a reflection of this terminal point. So they are just the conjugate of each other. So if you connect all of these 3 points together, you have an equilateral triangle. So it means that all these legs have the same distance. So now let us make a conclusion here. The cube root of 1 could either be equal to 1, negative 1 divided by 2 plus root 3 divided by 2i, or negative 1 divided by 2 minus root 3 divided by 2i. And hence, this is the solution to this problem. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.